Hello everyone, this is Mr. Molo for lesson 7-8, factoring polynomials completely. So this is another lesson. If you weren't using Punnett squares already, you're really going to want to use Punnett squares on this lesson. This is pretty much one of the big reasons why I like Punnett squares. Not only do I think it's easier for when you're doing other factoring, but I think it even makes this lesson a lot simpler. So if you'll notice, some of you might look at this and say this is going to be way harder because now there's 4 terms. But really, if you just make a Punnett square here and put what's on the inside, or what's in the question on the inside, it doesn't end up being that bad. So I'm just going to write what's on the inside there. So there's my b to the third, there's my minus 4b squared, there's my plus b, and there's my negative 4. And now we're kind of going to play like Battleship, kind of look and see where they meet. So I'm going to take my greatest common factor of these two, and I'm going to put it here. So my greatest common factor of b to the third and negative 4b squared is b squared. Same thing here. My greatest common factor between b and negative 4, well, they don't really have a common factor. One's a letter, one's a variable, and one's a number. So greatest common factor is just 1. Then we're going to do the same thing on top here. Greatest common factor between b and b to the third is just b. And then my greatest common factor between negative 4b squared and negative 4 is just negative 4. And that's pretty much what we do. That's our answer. Our parentheses are going to be b minus 4, and then b squared plus 1. So as long as you can put it in there and figure out the greatest common factor, you don't really have to do any guessing and checking then like we would normally. Like, okay, how can I get to b to the third? How can I get to negative 4b squared? How can I get to b? How can I get to negative 4? So there's not really a, okay, you need to multiply to get to this number and then add to get to this number. If you use Punnett squares, it's just going to be exactly like that, which makes a lot more sense then if you're doing problems like number 2, because number 2 looks kind of weird because it's just a bunch of variables. So same thing, I'm going to make my Punnett square and put them in there. So AC, AD, BC, and BD. Okay, so my greatest common factor between AC and AD is an A. My greatest common factor between BC and BD is a B. So one set of parentheses, A plus B. Next we have greatest common factor between AC and BC. Well, they both have a C in common. Then my greatest common factor between AD and BD. Well, they both have a D in common. So that means my other parenthesis is C plus D. That's my answer. One parenthesis, A plus B. The other one, C plus D. Okay, let's look at one that has a little bit more numbers, like number 4 here. So again, I'm going to put these in the parentheses here. So this one has 5t to the third. This one has 6t squared. This one has 5t. This one has 6. Okay, so greatest common factor between 5t to the third and 6t squared. Well, 5 can go into 5, but 5 can't go into 6. You could have 2 go into 6 and 3 go into 6, but those numbers don't go into 5. So my greatest common factor between 5t to the third and 6t squared is just going to be t squared. And then kind of the same thing as like the first one, my greatest common factor between 5t and 6. Well, 5 and 6 don't have a common factor. This one has a t, but that one doesn't. So greatest common factor is just going to be 1. So one set of parentheses is t squared plus 1. And then here we look at the vertical here. So 5t to the third and 5t. Well, they both have a 5 in common. This one has 3 t's. This one has 1. So they both have at least 1 t in common. So 5t and then 6t squared and 6. So they both have a 6 in common. This one doesn't have any t's, so we can't do anything there. So then my two parentheses are t squared plus 1 and 5t plus 6. Let's look at another one that gets a little bit bigger here. So I can't imagine doing this any other way because this would just be so much guessing and checking of what goes where and what. So this one you kind of got to be careful because they wrote it out of order, so Mr. Molo messed up there. So 8s to the third minus 64s squared, and then plus s, and then a minus 8. So be careful on ones like this where really it should be s squared before the s. So they tricked me there for a second, but I caught it, don't worry. So here, greatest common factor between 8s to the third and negative 64s squared. Well, 8 can go into 8, 8 can go into 64, so they at least have an 8 in common. And then s to the third and s squared, they both have an s squared in common. Greatest common factor between s and negative 8. Again, one's a variable, one's a number, so really all they have in common is a 1. And then if we look at the verticals, greatest common factor between 8s to the third and s is just s. And the greatest common factor between negative 64s squared and negative 8 is just a negative 8. So then my two parentheses are s minus 8 and 8s squared plus 1. Okay, let's look at one more on this page. Let's look at 8, because again, this one looks horrible if you're just doing guessing and checking, because there's so many ways to get to 21. There's so many ways to get to 18. There's so many ways to get to 35. So many ways to get to 30. I think if you're not doing Punnett squares, guess and check is just going to drive you crazy with these. So if I do a Punnett square here, 21h to the third, 18h squared, negative 35h, and negative 30. Okay, so greatest common factor between 21h to the third and 18h squared. So 3 can go into 21, 3 can go into 18. So my greatest number is 3. This one has 3 h's, that one has 2 h's. So the greatest amount of h's they share is 2. And then we have negative 35h and negative 30. And we figure out negative 5 can go into both of those. Negative 5 times 7 is negative 35. Negative 5 times 6 is negative 30. And then we look at the verticals. So 21h to the third and negative 35h. So the greatest common factor between 21 and 35 is 7. And this one has 3 h's, that one has 1. So they both have an h in common. And then the greatest common factor between 18h squared and negative 30 is 6. 6 can go into 18 3 times, and 6 can go into 30 5 times. So then you end up with 7h plus 6 and 3h squared minus 5. Okay. And if you look at the last page here, kind of the same things. It wants us a factor completely, but some of these already have a greatest common factor. So going to be a little simpler then. So we already have something in common between 4c to the third and 4c. They both have a 4c in common. So now you're going to take a 4c out of that whole thing. So if I take a 4c out of 4c to the third, I'm left with c squared. If I take a 4c out of 4c, I'm just left with that negative 1 that's sitting there. And then they want you to factor this as well. So you could factor that by doing c plus 1 and c minus 1. So when it says factor it completely like that, you're going to want to see what you can pull out first. Okay, same thing here. My greatest common factor between 100 and 25 is 25. 25 can go into 100, 25 can go into 25. And then my greatest common factor between x to the fourth and x to the second is x to the second. So again, if I divide those, I end up with 4x squared. And if I divide those, I end up with that negative 1 again. So, and then you can also split up the parentheses again. Whoops, forgot my x squared. So that could be 2x plus 1. And that could be 2x minus 1. And then number 11, if you're looking at it saying you can't pull anything out, you're right. This is a 2a to the squared. This is a 3a. That's a negative 2. So this is just a normal problem like we did a couple weeks ago. So I have 2a, so two numbers that multiply to negative 2 and add to 3. So I have 2a minus 1 and 2a plus 2. So that one might require some guessing and checking there for that one. Okay, and then one other way they're going to try and mess with you here, and unfortunately there's no way to kind of figure it out. They're going to throw problems at you like number 12. I will tell you right now, you can sit there and try questions like number 12 over and over again, but there is no way that you can figure it out. There's no way that you can multiply two numbers to get you negative 14 and then have that 9x there and still get positive 3 in the middle. So there will be some that are not factorable. Okay, I'll warn you about those on the homework, but that is a possibility on some of these questions. Okay, and then let's look at some of these bottom ones here. So this one, kind of the same thing as what we did up top, except now they want you to solve completely. Okay, so same thing of what we've been doing. So I'm going to factor out x minus 5 and 3x minus 6. So x times 3x gives me 3x squared. Negative 5 times negative 6 gives me 30. And then we can factor it out, except see how they say equals 0. So I'm going to set each part equal to 0, just like we've done a couple times before in this chapter. So add 5 to each side, add 5 to each side. So x equals 5. Then I got 3x minus 6 equals 0. So add 6, add 6. So I got 3x equals 6. Divide by 3 and divide by 3. So I figure out x equals 2. So kind of the same thing that we've done before. I'll do one more just so we can kind of see it. Let's look at number 22. So this one, we got to do some work here. So I got to subtract 16x, subtract 48 from each side. So I'm left with x to the third plus 3x squared minus 16x minus 48. Okay, so let me make my Punnett square here. So x to the third, 3x squared, negative 16x, and negative 48. So my greatest common factor between x to the third and 3x squared is just an x squared. My greatest common factor between negative 16x and negative 48 is a negative 16. And the verticals, greatest common factor between x to the third and 16x is just x. Then my greatest common factor between 3x squared and negative 48 is just 3. And now you'll notice something a little different with these parentheses now. I'm not done yet. And the reason I'm not done is because I can factor this out more. So x to the third can't be factored out more, but x squared minus 16 can still be factored out into x plus 4 and x minus 4. So got to be careful if you ever get these perfect squares here and it says squared, then you could still work. Okay, and then otherwise it's still basically the same thing. So x plus 3 equals 0. X plus 4 equals 0. X minus 4 equals 0. And then you're just doing the one step of math, subtract 3. So one answer is x could be negative 3 to make the equation equal 0. Subtract 4. So x could also be negative 4 to make the equation equal 0. And x could be positive 4. So that could be one of my, or those are your 3 possible answers where if you plug those in, your equation would end up equaling 0.